All right, so we are going to be finding logarithmic functions that fit contextual data. And so this first example, well, just an introduction. And this scatter plot gives you the average salary of U.S. pastors based on the size of the church. And so what shape does, or what functional, I guess, shape does that form? Like, what does that look, what type of graph does that look like? It's a log graph. So that's going to be a log graph. It is going to be concave down, and it is increasing everywhere, but the rate of change, is the rate of change increasing or it is decreasing? Good. So there is a higher rate of change at the beginning, and then it starts to decrease, or it's decreasing the whole graph. Anyway, some information, some review on things. And so they're just like when we did quadratic regression or quadratic models, exponential models, there's lots and lots of real world applications or scenarios that go with those. Same thing with logarithmic. So logarithmic patterns are used to measure earthquakes and sound and acidity and a whole bunch of other types of things. All right. And so we are going to use the regression features in the calculator sometimes with logarithmic, and then there is about half the time we won't be able to for the problems that we're doing. And so whenever it looks like this, where it's a plus b natural log of x, that's when you can use the regression features in the calculator. And the choice, when you go to stat calc, is choice 9. And it's L in reg for the natural log regression. But if it is any other type of log, then we can't. We can still use the calculator to figure out some values, but we can't use the regression in the calculator. So we'll go through these, and each one I'm going to ask you, can we do the regression in the calculator, or do we have to do it another way? All right, so this first one, we just have a table of values. It doesn't have contextual information attached to it. And we are going to find L, where L of x is a plus b natural log of x. Can I use the calculator on this one? Yes. So I'm going to see if you guys can remember how to do it. So, no, just kidding. We'll hold off on the calculator for a second. Part A says to use the given data to write two equations that can be used for the constants a and b in the expression L of x. So that should sound extremely familiar. We've probably done 50 problems like this, maybe not that many. None of them have been natural log, but we've done these two equations so many times. And so if we're looking at this first point, and we're putting things in here, what am I going to put in for L of x? Which one of those is L of x? 3. And then A and B are A and B. And so for this first point, what am I going to put in for x? 2. Good. All right, and then you guys go ahead and do that same thing for 5, 7, please. All right, so that gives you a point on the AP test. It's a very, very easy point to get if you're just taking your time and going slow. So be careful with that. All right, and then the next point, especially if it's a calculator problem, is also pretty easy to get. So what we'll do, since we already said we can do this one in the calculator, is we're going to put this table in the calculator. So I want everybody to do it. Everybody's calculator should be open. Typing in some values. I'm going to remind you how to clear your lists. But go ahead. What do I hit? edit. Okay, you're right. All right, and then this actually is what I want, but you're gonna have other stuff in there. So up, clear, enter. Put in the data, please. Okay, and then where do I go to get this regression equation?
Stack calc.
Nice. Stat calc. And then, oh, I hit the wrong thing. Stat calc. And then if you have one of these newer calculators, you can see it. If you have one of the yellow calculators, you're going to have to scroll a little bit or just hit 9. And then I am going to store it. Do you guys remember how to store it? Alpha trace. Now we don't technically need it for this particular problem, but I just like to be in the habit of storing it. And then all you have to do is say what A is, accurate to 3 decimal places. So go to 4 if you're worried about being accurate to 3. But you can either round or truncate. And so for A, you can say 0.025 or 0.026. Both are 100%, right? And then for B, there is only one answer, which is 4.365, unless you go to more decimal places, and that is always perfectly acceptable. All right, so hopefully that feels super familiar. Let's look at this one. This one's going to take a lot more time because we have a lot more values to plug in. So this is the table for that data we looked at the very beginning of the lesson, where P here is going to be the church size, so I guess the population, and then S of P is going to be the average salary of the pastor in thousands of dollars. Okay, this is the model we're using. Can I do the calculator? Yeah, it's a good thing also because we wouldn't be able to do this one otherwise. It's just way too many points. All right, so you guys, I want to hear a whole bunch of clicking. So put these in. The church size, I know it goes across, but you're going to go down. And then same thing for average salary. That's a lot of numbers, yeah.
Scared me.
What's wrong?
What are we supposed to write for A? What answer are we supposed to
Okay, so for A, the answer is going to be S of P equals take your A, and put it first, and then plus whatever the B is, and then L and P. All right, what did you guys get for A?
I got -21.5.
Very good. And for B?
29.9 to.
Okay, you can do 8 or 9, it doesn't matter. And then just make sure you use the variable in the problem. So I don't know how picky someone grading your test would be on this, and I don't know if it would even come up on the free response, but if P is the variable, make sure you write the P. All right, anybody have a question about that? That was a lot to type. Some of you are faster typers than others. Did you all store it in Y1? Okay, good. Because we actually needed to do that on this one just to save us some time and to make sure we're not rounding too many times. So for B, we're going to use the model found in part A, or using it. What is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people. So where are we going to put that 500? In for P. Now, if you stored it in your calculator, then you can just go to the regular home screen, type Y1, and then in parentheses do 500. Now, this is in thousands of dollars. And so when I did this, I got 94,000, either 330 or $329. All right, what questions do you guys have? All right, so try to remember that you only round once. So storing that in the calculator means that this number is not going to be distorted. If you actually typed it in here and here, it's possible, I didn't try it that way, or put it in here with these numbers, it might be off a little bit. So just be careful. Your calculator stores all the decimal places. Okay, so let's look. This is just a reminder that you can only use the regression features in your calculator when it's this form. So let's look about this one about intensity in decibels. So the most common and preferred method to measure sound intensity levels is in decibels. The sound intensity level beta in decibels of a sound having intensity I, which is in watts per meter squared, is modeled by this function. All right, A and B are going to be constants. And so we know that the sound of noisy traffic has an intensity of 1 times 10 to the negative 5 watts per square meter, and it corresponds to 70 decibels. So let's just take that information. Let's just go ahead and start doing part A. So what am I going to put in for beta of I? The decibels or the watts? We're going to put in the decibels. So this beta gives you decibels. So that's going to be 70 equals A plus B log. And then in the place of I for intensity, we're going to do 1 times 10 to the negative 5. Now, that seems weird, because what is 1 times 10 to the negative 5? It's just 10 to the negative 5. So, but from what I'm seeing on these problems with intensity, they always put intensity in scientific notation, which is fine. We'll just go ahead and use their numbers. It's no big deal. Okay, and then go ahead and write the equation for the second one. So a loud concert has an intensity of 1 watts per meter squared and corresponds to a decibel of 120. All right. So can I use the calculator on this, or can I use the regression on this? No, because it's log. It's not natural log. All right, so on most of these problems, one of these equations is going to have a 1 as the argument. And that's the one we're going to focus on first when we're doing these algebraically. So I'm going to start with that one. And I'm going to try to do as much of this as possible without a calculator, but you can use a calculator. So if you just completely forget what log of 1 is, it's okay. You can type it in. But this is like trying to figure out 10 to what power gives you 1? 0. So anytime the argument of a logarithm is 1, the answer is going to be 0. So what that means is this is like A times B times 0. So A is 120. Fire. Thank you. Oh. All right, so what do you think we're gonna do now with that 120? Now that we know what A is. Right, we're going to plug it in. We're going to take it, and we're going to put it into the other equation. We're going to put it into the green equation. Fun fact is in my way. So maybe we can fit it. Okay, again, we can use our calculator on this, but I'm going to try to do as much as possible without it. So we would just go ahead and solve this for B by subtracting that 120. Now we already said 1 times 10 to the negative 5 is just 10 to the negative 5. So if you wanted to try and do this without a calculator, since this is base 10, you would ask yourself 10 to what power gives you 10 to the negative 5? What would you answer yourself? Negative 5, yes. Now, if you don't want to ask yourself that question, you can type it in. Your calculator will tell you everything on this. So log is the button just right beside 7 when it's log base 10 or common law. All right, so this means that B is going to be negative 10. Oh, positive 10, just kidding. All right, so that's how you do it without the regression. It's nothing too crazy. It's a little bit of algebra. All right, and then C says that the human eardrum can burst when sound reaches an intensity level of 1 times 10 to the 4th watts per meter squared. According to this model found above, what is the predicted number of decibels required to burst a human eardrum? So we're going to put that 1 times 10 to the 4th in for the beta or for the I. I is intensity in this problem. So we do need to write the equation, I guess. And you can just type that in the calculator if you want to. If you want to try and do it in your head, log of 1 times 10 to the 4th is just going to be 4. And that is going to give us 160 decibels. What questions do you guys have? Okay, we have one more to do. And I know this is really hard to believe, but in May of 2011, 65% of adults did not own a smartphone. And in November of 2016, only 23% of adults did not own a smartphone. So the percent of adults that did not own a smartphone can be modeled by this function, where S of t is the percent that don't own the smartphone, and t is the number of years since May 2011. Look at it very closely. Can I use the regression features on the calculator? Hunter's saying no. He is right. You cannot. Why? What is the problem? It is a natural log. The plus one, yes. So whenever we can use the regression, it just has to be natural log of t. A plus b, natural log of t, or natural log of x. If there's addition in the argument, it's not happening. So it's okay. We can still do this. Okay, so we're going to write our two equations. We should be super good at this. So for the 65%, are we going to put that in for S of t, or is that going to be a t? That's going to be a S of t. And it actually tells you t is 0. That's very helpful. And then the other one, it tells you t is 5.5 and it's 23%. Now, if you go ahead and add the 1 on that step, it's fine. Like, you don't have to. You get the point. If you write it exactly like this, you get the point. But if you add the 1, you still get the point. We have to add it eventually. Okay. So which one of these do you think we're going to use first when we go to solve this by hand? The top one. So we would be 65 equals a plus b natural log of 1. What is the natural log of 1? 0. So a is just 65. And that's really all you would need to write on that. So we're trusting the fact that you know that that's just, this whole side is just going to be 0. Okay, then we're going to take that 65 and we're going to put it in for a. And we're going to solve this for b. We're not going to type in the natural log of 6.5 until the very last step. And so the first thing we would do is subtract that 65. Right. And then what are we going to do to solve this for b? We don't have to do it exponential. We would divide by that natural log of 6.5. And now we're going to type in the calculator. So please wait until you're done doing all the algebra to type it in. Because if you do it too soon, it's possible that your rounding is going to be messed up. So at this point, I would just do that alpha y equals to the negative 42 over the natural log of 6.5. And then be accurate to 3 decimal places for the b value. Do you guys remember how to do, because we can see log and natural log, they're really easy. But what about like log base 2? Do you guys remember how to get that? Alpha window, good. Alpha window 5. And you can make it be any base you want it to be. All right. What questions do you guys have?